All right, guys. Last time we talked about permutations. This time we'll talk about the other side of that, which are combinations. At the top up here, you'll see the formula for combinations looks really similar to the formula for permutations. The only difference is you have this extra little r factorial in here. What that r factorial does is it kind of takes into account that order doesn't matter. So with combinations, order does not matter, where permutations, order does. So permutations are reserved for situations where the order in which things get picked makes a difference in the total outcome, where combinations does not. So combinations are a distinct set of objects without regard to arrangement. And notice that either way, combination or permutation, repetition is not allowed. So, for example, these are two situations. One of them is a permutation, one of them is a combination. So if I look at part A then says, how many ways can you choose a captain and an alternate captain? So in this case, whoever gets chosen first is captain, and second is alternate captain. So, if option A and option B, but if you switch them, then now the second person is now captain, the first person is now alternate captain. So the order in which people are chosen matters. So anytime you get to a problem where the order matters, that's going to be a permutation. So, like I said, if you switch the order, now somebody else is captain and not alternate captain. So it creates a different situation. Now, if the coach just wants two starters, so, if you're chosen first or second, it doesn't matter. You're still talking to the coach. It doesn't change your position. You're still a starter. So in this case, when you choose two people, the order in which the two people are chosen makes no difference. So that would be an example of a combination. So permutations, order matters. Combinations, order do not. So the only difference as far as the notation is instead of a P, we use a C. So we have in CR. So that's a combination instead of permutation. So it's in choose R. So you have in number of objects and you want to choose R of them. So 5 choose 3 or things like that. All right. Now keep in mind again, it's in factorial over n minus R factorial, which is the same thing as permutations, but we're going to add in this extra r factorial to take into account any of the ones that where the same people are chosen. Again, regardless of order, it could be 1, 2, 3, 3, 2, 1, 2, 3, 1. This little r factorial takes into account all of those things being the exact same. All right. So if we look at these examples here, the first one then says, so how many ways can you select two different vowels where order doesn't matter? And again, anytime you see this order doesn't matter, that right there is indicative that you're talking about a combination. Okay, so anytime order doesn't matter, that's a combination. So in this case, again, like I talked about last lesson, we have 5 total vowels, of which we want to choose 2 of them. All right. So again, if we go through our formula, we have this 5 factorial over, and again, we're going to have n minus r factorial times r factorial. So this is just 5 factorial over 3 factorial times 2 factorial. And again, you can multiply it all out, but the bottom line is you get 20 over 2, which just gives me 10. So there's 10 combinations of choosing 3 out of those 5 vowels. Or should be 2 out of those 5 vowels. Okay? So again, it looks very similar to what we did last lesson with the permutation stuff. We just have this extra little factorial down there to take into account that order doesn't matter for these. All right? So if we look at the next example, we have the president invites 10 faculty members to lunch. There's room for 6 members in this car. So if he's only going to choose 6, how many different combinations could he choose? So in this case, again, it doesn't matter what order you're chosen in. You can be 1 through 6 or 6 through 1. Still the same 6 people no matter what. So, one does not get more privilege over the other. You just want to be one of the 6 that's chosen. So again, that's a combination because order doesn't matter. So we've got 10 faculty members, of which we want to choose 6. So that's going to be a 10 choose 6 question. And again, that's going to give us 10 factorial over n minus r factorial times r factorial. So we have this 10 factorial over 4 factorial, 6 factorial, which again, you use a calculator, multiply it out. You're going to get 210 different possible combinations of faculty members if you have 10 of which you're going to choose 6. All right. Example 4, very similar. You have 6 question tests. All right. You're required to answer 4 of them. So how many different ways could you how many different ways could you organize those 4 questions? Again, it doesn't matter which order you do the questions in. It just matters that you do the same 4 questions. So again, order doesn't matter. So you've got 6 total questions, of which you're going to choose 4. All right. So again, we have the 6 factorial over, we know 6 minus 4 is 2 factorial, and then the r value is 4 factorial. Again, use the calculator because it's all calculator active type stuff. So plug it in, and there are 15 different options of 4 questions that you could choose. So again, you could choose 1, 2, 3, 4. You could do 2, 3, 4, 5, 3, 4, 5, 6, 1, 3, 4, 6. So those are the different combinations of questions that you could potentially answer. But again, what combinations does is it counts 1, 2, 3, 4 the same as 4, 3, 2, 1. You're still answering the same 4 questions. All right. So in this case, the order in which doesn't matter. All right. So 5, very similarly. So you have a pizza place that has 3 toppings. All right. There are 8 different toppings to choose from. You have to choose 3 of them. And again, if you choose pepperoni, cheese, and mushrooms, you can choose mushrooms, cheese, pepperoni. You still get the same 3 toppings on the pizza. So again, this is an example of one where order doesn't matter. So you have 8 total toppings, of which you need to choose 3 of them. So this is going to be an 8 choose 3 question. So that's going to be 8 factorial over 8 minus 3 is 5 factorial. The r value here, again, the number you're choosing is 3, so 3 factorial. All right, which is going to end up giving us 56 different choices if we have to choose 3. All right. Now, this is an example that has like a multi-step part to it. So, you go to a caterer, you've got 6 meats, 8 veggies, and 5 desserts. All right, you need to choose 2 meats, 3 veggies, and 2 desserts. So how many different selections are available to you? So again, you're going to take it kind of a case at a time. So the first part, you're brought the meat menu. All right. And so you look, and there are 6 total choices, of which you're going to choose 2 of them. All right. So that's our 6 factorial over 4 factorial, 2 factorial. And so we have 15 different choices for the meats. All right, the next thing that come out is the veggie menu. Okay, and for the veggie menu, again, you have 8 total vegetables to choose from, of which you're going to pick 3 of them. So we have this 8 factorial over 5 factorial, because again, it's 8 minus 3. 3 factorial, and that's going to give us 56 different options for the vegetables. And then lastly, you have desserts. And of the desserts, again, there are 5 total desserts, and you're going to choose 2 of them. So that's going to give us this 5 factorial. 5 minus 2 is 3 factorial. The r value is 2, so 2 factorial. And you have 10 total choices for that. Now, to figure out how many choices you have overall, you're going to take each of these numbers and multiply them together. So we have 15 choices for the meats. We have 56 choices for the vegetables. And we've got 10 choices for the desserts. So if I multiply all of those things together, that'll give me the sum total of options that I have. So if I multiply this together, I have 8,400 different choices of combinations of food that I could choose from this catering company. All right. So same as last time, if you need some help, there's a really good, overview at the very bottom down here. It goes through everything we did for the past 2 lessons, so both combinations and permutations. So counting principle, again, remember that's just the number of distinct ways and 2 different experiments could be, outcomes could have. You have permutations where order does matter, and then you have combinations where order does not matter. All right, down at the bottom down here, again, there are some practice questions for you guys to look at, so work on those. They go along with the notes. So if at any point you have questions about them, go back through, look at the video, pause it, slow it down if you need to. And again, if you have questions, make sure you email your teacher and we'll be happy to help you. Have a great day.